Hi, good morning. My name is Puertas, Calvo. I'm a scientist in the Identity Security and Protection team at Microsoft. And I'm going to talk to you about how we use machine learning to protect all the users of all of identity systems, using machine learning without damaging their productivity and their usability. So, artificial intelligence, right? These are the marketing images that you get when you go to like security conferences, like say or Black Hat. Basically, you get this like awesome magical box where you can plug in on your logs, and it's going to give you the best insights. It's going to tell you everything about the data. It's going to tell you the bad guys, the good guys, everything. But when you work in this field and you go to the other conferences, the ones where the people that are actually working on the technical stuff, not the marketing stuff, it looks more like this. Doing machine learning and doing artificial intelligence is really, really hard. Doing it for security, it's a lot harder. I talk to a lot of people who are trying to do it. Some people do it really well. Other people really struggle with it. And we also had a lot of challenges. This is what people tell us when we talk to other companies or people who are trying to do it. Some people say rules and heuristics work better. I can get the same performance than using machine learning. They're basically like giving up because they've tried and have failed. Or I cannot do supervised machine learning because I don't have any labels to label my data with. Other people say, well, I have a good model and it works, but when it makes a mistake and it blocks my CEO from accessing like an app, how am I going to explain it? It's a black box, and I can't explain how the algorithm decided to do this, so I'm not going to use it. And a lot of other reasons, like I cannot measure its performance, so I don't know how to model degrade, so it's just like hard to understand. At Microsoft, we also face all of these issues. These are not unique to like specific people. Everybody faces them. We really, and we found ways to make machine learning work for security. Today, we run machine learning for all of our user interactions with all of our identity systems. We have supervised machine learning running in production in real time for user logins to detect risk of how risky that login it is for it to be like a legitimate user or for it to be compromised or be a hacker. We also have machine learning running in our IP addresses, detecting when IP addresses are attacking us, when they're good IP addresses, when they're corporate IP addresses from our customers. We have machine learning determining what the user risk is based on their past history and their past activity. We basically run it everywhere. So in this talk, I'm going to tell you, first of all, why do we need this machine learning? And this one's going to be a pretty obvious one because we all understand how important it is to have security in identity. Then I'm going to tell you how, with machine learning, we can increase the security dramatically with like very little impact in user productivity. And we do this by putting the machine learning right in real time in the interactions with our front ends. And finally, I'm going to give you a few tips on how, at Microsoft, we overcame all of these challenges and what are the different things that you can do to surpass these problems and make it work and have machine learning running in production for security. So the why, just real quick, because this is really obvious, right? Today we have our identity systems that are open to the world. We have mobility and we have cloud, and users are accessing their applications from anywhere in the world, from mobile phones, from any kind of device. That's where like the identity is the place to be. If you're an attacker, it's the one place you're going to attack. We've seen a huge increase in phishing, password spray, which is a low way of brute force attack where the attacker is just using the most common password to just try to get into some users because they know they're going to get into them. Or breach replay, like when a company breaches and then those credentials are used to attack any identity system. So it's obvious that we need to protect our users, but our customers don't want to do that at any cost. We don't live in the world anymore where like you could just put a firewall and then have all your users working in corporate network, right? everybody wants to access from everywhere. So how do we maximize security but not affecting the productivity of all of the users? It's by putting the models and the decisions of the risk right with the interactions with an identity system. So if we can build machine learning systems that are smart enough, they're going to let the good users go through seamlessly and authenticate or do whatever interaction they need to do with the identity system. And at the same time, they'll know when a bad guy is coming through, and they'll be able to stop it. So we put machine learning on the users, the devices. We know location reputation by using, looking at the different IP addresses that the traffic that comes to our IDP. We know risks and applications. And then we can build a machine learning system that risk scores every single interaction that happens, like every authentication, any sign up, password resets, all kinds of identity interactions. So when the risk engine decides risk of the interaction is high, we can do things like deny access, just block this authentication. We know this IP is attacking us because the machine learning system has decided that. Or you can put extra friction. You can decide to require factor authentication. But for the majority of the good users, this is going to be seamless. They're just going to get a low score of risk, and they're just going to go through magically, and they're not going to see their productivity affected. Another reason to use machine learning is the adaptability of it. So when you're doing security, we live in a world that it's not static. It's constantly changing and adapting. When you have a machine learning that's trying to distinguish between a cow and a sheep, the cow and the sheep are always going to look the same. But when you're doing security, it's a game where like you're detecting bad guys, and then the bad guys are going to try to attack and hide from your detections. If you are just building rules and heuristics, and you have security people building these detections that are manual, it's going to be slow because you're going to have to find the attack, and then you're going to have to respond to it, and then you're going to have to deploy the new rules into your front ends, and that's going to be like an expensive and slow game. If you build a machine learning system that's fast enough to adapt, where you can actually like train on a daily basis or maybe like even an hourly basis, and you can learn from the latest attacks really fast and deploy those models automatically into your front ends, you're not only saving a lot of cost, but you're also preventing a lot more attacks by doing that. So like this chart is big, but basically you can see like a user's logging in at the top. The classifier decides what to do with that login. You can block it, decide if it's good or bad, basically. And then we have systems that run afterwards that make the decisions by looking at a lot more data of was the first prevention system right or wrong, and then we use that information to update our models and deploy it automatically in our front ends. So that way, everything is done automatically, and you save a lot of cost. So now, how did we overcome all of these problems that I was talking about? I'm going to tell you about 4 different things that we did that make us have successful machine learning running in our identity security. Number 1, be a domain expert. I'm going to go into detail in each one of these, but this is about knowing your data really well. Number 2, build defensive layers. Start simple, build a machine learning on top. Invest in labels. This you need to get really creative and know where to get your label data from, because this is the only way you can build supervised machine learning models. And finally, numbers. Measure everything. Measure the outcome of your models and the performance of your system so you know to go invest next. So number 1, be a domain expert. Start your own data. Know good versus bad. Know the logs. You need to understand the engineer who coded the login system, what he meant with every single value that is logged in your logs. You can't just hire a data scientist out of grad school and give him the data, like build me a model. It needs to be, the data needs to be really understood so you can know what it is that you're looking for. And I'm going to give an example of like why this is important. Basically, this is called feature engineering, and it's the craft of transforming your raw data that it doesn't really mean a lot to your models into data points that are actually really good at discriminating the good versus the bad when you're doing security. So in this chart, in this table, we see a few logins from a user named Alice that is logging into Azure Active Directory, several apps. And this is just like a subset of just one user, like of billions of logins we get every day. And if we give the machine every single one of these logins individually to risk score on real time, it's not going to be really good. When we look at all of the logins of Alice, though, all together, we automatically can see that there's one that stands out, right? We see the one at 2 or 4 in the morning from a Linux machine in Russia. When we look at, if we didn't know anything about Alice, if we didn't have the rest of the logins, we wouldn't know if that would be good or not. Because we know the pattern that Alice normally logs in, we understand that that login looks anomalous. So being a domain expert is understanding this, and doing feature engineering is transforming this data into that data that is like more useful model to understand that that login is actually bad. So we know that Alex doesn't normally log in at 2 in the morning because we see it in her pattern, right? We know that this Linux machine seen it before for Alex. She only uses Exchange and Salesforce, but now she's accessing SharePoint. That's maybe a little suspicious. We can also have metadata coming from other offline analysis we've done that we can attach to the model about the IP address that she's coming from. Because we have a huge IDP, we can see all of the users that are calling us from this IP address. And maybe like a lot of other users from a lot of different tenants or for a lot of different customers logging and using this IP address. So that's valuable information. Also, we know that we've never seen Alice in Russia, so that's also interesting. So now what feature engineering is codifying all of this into what I just talked about. So we can have features talk like, is this normal time of the day for Alice, 2 in the morning? Or is this a familiar device? And we can also add features about the metadata of the session. So do I know what's the risk score for this IP if I've seen it before? Can I have a reputation assigned to it? Or do I have a risk for this user based on their previous activity? Maybe it's going to tell me more information about how risky this session is. So basically, be a domain expert means you're able to do feature engineering and do it right, and your models are going to work better. 2 is build defense in layers. So this is about, this is really important. At Microsoft, we never start building machine learning first for a new problem. You start with the low-hanging fruit. You build rules and you build heuristics to try to catch like the bulk, the volume, the unsophisticated attackers. Once you've nailed it all down, you build the machine learning on top. We see our defenses in 3 different phases. Prevention, which is when stopping the bad guy before any damage. Detection, which is runs after the fact, tries to detect bad activity that already happened. And mitigation, remediation, which is what happens after these detections and preventions occur. So, for example, did the user solve an MFA challenge, or did do a credential reset, et cetera. So for all of these phases, when we're trying to do the prevention and detection phases, we start with rules. We have from applications that the users are logging into. They have their own security teams working on detecting bad activity. We do that. And then after that, we put the machine learning on top. So the machine learning helps us refine, help us find the more sophisticated bad actors, and also reduce the false positives that are, or more rudimentary systems we're making. And we also do this by feeding everything from the later phase into the previous phase. For example, when a user solves an MFA challenge that was a result of a prevention, that means the system was wrong, or if he was actually the good guy. So we tell our prevention system, hey, you were wrong about this, so then the next time it learns from its own mistakes. The next one is invest in labels. Labels are the truth that you're trying to effect. It's the one thing you don't know that you're trying to your system to guess, right? So like, where do you get this in security? Basically, a label data set will be trying to classify sign-ins. It will tell you which sign-ins are legitimate and which are compromised. But bad guys are not going out there selling data sets of their logins that they compromise other users, right? They're doing the opposite. They're trying to hide from us. So you got to get really creative of getting labels. Basically, you need them for two main things. One is to train your supervised machine learning models. In order to tell your model what they need to look for, you need these labels. And then you also measure your model quality, because you need to know what sessions that your model detecting as bad are actually bad. And you can know how well your model is doing. So here's how we get our labels for all our systems. The first one, the easiest one, the best one to go do when you're starting is like the end user generated labels. If you build feedback loops into your systems and you have your customers, like the admins or SecOps, you build buttons, hey, this session was compromised, hey, this user is compromised, or the opposite, you made a detection and they give you feedback, this was a false positive, and you do this in an automated way, you're gonna get a for free. Customers want to give you this data, so put it in there. With a caveat that sometimes users are not right about this because they're also not experts in it, so you just have to make sure that you build smarts on top of that data and remove the errors. Number two will be expert-generated labels. So this is data that can come from security researchers that if you have them in your company and they're detecting big attacks, they can tell you about it. You can use it to label your data. Customer support test data that you've been compromised, so you can also use that to label your data. Or you can even have a team of dedicated analysts who are just tasked with tagging your data. They just you train them and you show them all the possible contextual information about the thing that you're trying to label, and they can label it for you manually. That's pretty expensive, but it's really good if you just want to do it in low volume and then use those specific, very good, high-quality labels to determine the quality of the rest of your labels. When you need big volume, if you're doing big data, you're going to have to find ways to auto-generate your own labels. We do this by, and this ties to the previous slide, we build very, very accurate heuristic detections that detect basically the bulk and are really accurate. So when you have a detection that is 99%, you can use those detections to label your data and ingest it into your machine learning systems that is going to then detect the things that you didn't detect because they're the most sophisticated patterns. And lastly, you need to know your numbers. So what I mean is you need to measure everything from the outcome of your models before you deploy them. I've actually heard lots of scary stories about people who build a model and they test it with few anecdotal, facts, and they're like, oh yeah, this works, I detected it, and then they put it in the front end, and then they start stopping every single user that maybe comes from Nigeria, even the good ones, because that's all the model does is stop you if you come from Nigeria. So make sure you have good data to measure. You need to measure your precision, and you need to measure your recall. And you need to measure them constantly, not just before you deploy your models, but after they go into production too. You need to understand how your model's doing, so you know where to invest next. You need to know what you're missing. You need to know what you're doing right, and you need to know what you need to go and improve. But also, one of the main reasons to measure is because every single model and machine learning system, and even heuristic system, is going to always make two types of mistakes: false positives and false negatives. So you're either going to be blocking or putting friction in some good guys, or you're going to be missing and letting in some of the bad guys. The compromise between these two errors, it's your operating point that every single company is going to have to decide where to put at. So you need to know how your model is performing in order to decide what percentage of attacks are you going to stop by putting X amount of user friction. The better your models are, the bigger the percentage of attacks you're going to stop with the least amount of user friction. There's going to always have to be some compromise unless you're able to build some system that has 0% false positive and 0% false negative, but let me know if you're able to do that. So that was the 4 things. I'm just going to summarize them. Be a domain expert. Make sure you understand your data really well so you can do feature engineering successfully. That's going to help you immensely. If you have good features, your models are going to be so much better. Second, build defense in layers. Don't start with machine learning. Start simple. Use heuristics. Try to detect the unsophisticated bad guys, and then you can put the machine learning on top, and that's going to improve what your heuristics are doing. Invest in labels. Be creative. Figure out where to find these sources of intelligence, so then you can tell your models to detect those things. And finally, make sure you measure everything so you can know where to invest more and what your operating point is that you need to decide by yourself based on how risky your customers are willing to be or how much friction they're willing to have. So thank you so much. I'll take questions. Before that, if you have questions later, you can find me at the booth. And also don't miss talks by my colleagues today at 2:30 with Dana and Nitika, and tomorrow at 1:15, the keynote by Alex Weiner. They're both also about identity security. They're going to be really interesting. Thank you. I'll take questions. So a heuristics is, it's basically rules that you're creating to determine then if something is good or bad when you're doing security, or if something is classified as A and B. So for example, I could have the same feature, do the same feature engineering that I described, but instead of fitting it to a machine learning model, I could just decide what to do about it. So I could say, okay, I have a feature that says, I've never seen this user in this country before. So a heuristic would be, if a user comes in and I've never seen them in that country before, then I want to elevate risk to high. That would be a heuristic. While the machine learning would be I'm just going to train a model with tons of data, then that's just going to decide where to put those thresholds by itself, instead of me telling where the thresholds are. Yeah. So in our team, we own the security and protection of all our consumer, all our cloud identities. So the consumer identities, like Microsoft account, and all our cloud enterprise identities, so Azure AD. So it's all of it.
Second question, you talked about the domain. Can I overlay my enterprise domain, the knowledge of saying that, this person is help desk, this person is privileged user, or these customers have this products, those kind of things, on your model, and then say that make it more intelligent? Can I overlay models on your model? Do you publish your model?
No, we don't. No.
How do we manage?
You can give feedback. So if you're a security admin or a SecOps person, and you're monitoring your environment, you're monitoring your attacks, and you use our security products, you can give feedback about if something is happening. For example, if we're detecting, if we're giving risk to your users and you go investigate and you see, oh, this was a false positive, this user wasn't actually compromised, you can give feedback on it, and then our model would learn from it.
But I cannot train it saying that these products and these users. Okay.
Yeah. Yes?
Thank you, Maria. Great talk.
Thank you.
So I took a snapshot of one of the slides. Are the slides available online?
Actually, I don't know how that works.
So one of the slides showed it was the maximize security, maximize productivity.
Yes.
It showed machine learning, and then it fed into the real-time risk engine.
Yes.
Talk about this fed into the real-time risk engine from the machine learning.
So the machine learning, you can just think about it as the back-end offline training of the model. I guess from that chart, I can go back to it. That's what it meant. This is slow. So okay. Oh. So the real-time risk engine will be at the time that a user is making an interaction with the identity system, the real-time risk engine gets inputs from the machine learning, but also other things we have in place. Like, for example, it's in an anonymous IP address, or Is it like an unfamiliar location? And so that will be like the part where like real time at the time of the login, it will get all the inputs and evaluate what the risk of that session is. The machine learning part is just like one of the things that feed into it. So offline, we'll train a model with all the data we have from like good user, bad users, and like the model will be created, and then it will be deployed into the front ends. So every time a new interaction comes, the model runs and gets evaluated with the data from that session and make a decision about the risk. Yes. Thank you. No, the intelligent security graph is about how all the different products and teams within Microsoft that do security basically share their information into, so like everybody and all customers can benefit from it. There's actually a good, we have a slide on it, but I actually took it away from this presentation, and I don't know if any of my colleagues later have it in their talks or not. Yes.
So your machine learning, does it classify your users into just good and bad, or do you classify into more categories?
So any machine learning system really is going to give you a score, a probability of the whatever you're trying to detect, the interaction being good or bad. So it's going to go from 0 to 1, and then you decide where to put the threshold. So for AED, we classify all of these things into high, medium, or low, or nothing. So it can give you like this user is high or this risk is high. Yeah. I don't know how much more time I have. No time? Okay. I'll be taking questions offline. You can find me now around, or I'll be at the Microsoft booth until noon or so. Thank you.